Students, today we are going to discuss potentiometer, which is a very important topic in current electricity, and also which is very important question for board examinations. So this is how potentiometer looks like. This potentiometer consists 10 meters of manganese wire of a uniform cross section. All the wires are arranged in parallel to each other, and they are joined by copper strips. These are copper strips. These are joined by the copper strips, and the two ends of the wire is connected to series resistance, a battery of EMF E, as shown in figure. So now we want to find out what is the current passing through the circuit in potentiometer. So the current passing through the circuit in potentiometer is I is equal to total EMF. How much total EMF here? Total EMF E by total resistance. Total resistance means here this is the series resistance and this is the wire resistance. The wire resistance is nothing but R and internal resistance of the EMF battery. So total EMF by total resistance R plus RS plus R. This is the total current in the circuit. Now, what is the principle of this potentiometer? On what principle it works? So, the principle of potentiometer is nothing but the potential difference between any 2 points is directly proportional to balancing length or length between the 2 points. So now on the wire we want to find out the potential difference between the 2 points A and C. How we can find out? Let us discuss. V equal to, according to Ohm's law, IR. V equal to IR. I. Here the length between A and C is nothing but L. Okay. The resistance per unit length of the wire. The resistance, total length is capital L. The resistance, total resistance is R. The resistance per unit length of the wire is nothing but rho. So now we want to find out the resistance between the 2 points A and C. So what is the length between the 2 points A and C? L, small l. Okay. Now resistance per unit length is rho. Then resistance for the length L is L into rho. So here L is the distance between the 2 points. L is the distance between the 2 points. Now, if current flowing through the circuit I and resistance per unit length are constant, then we discuss V proportional to L. We find the relationship between potential difference between the 2 points and length between the 2 points, V proportional to L. This is the principle of potentiometer. So in examination, this principle of potentiometer asked as a sub question. What is the principle of potentiometer? Principle of potentiometer is the potential difference between the 2 points on the wire is directly proportional to the balancing length or length between the 2 points. Okay, now we discuss some applications of potentiometer. First of all, what is the use of potentiometer? Why we prefer potentiometer to measure the potential difference between the 2 points in a circuit than voltmeter? Here one advantage is potentiometer does not draw any current from the source. It does not draw any current from the source. So it works in balancing condition, so that it does not draw any current from the source. But whereas the voltmeter draws some current from the source, so that it may not measure the potential difference accurately. That is the one advantage of potentiometer over voltmeter. And also, by using the potentiometer, we can easily determine the internal resistance of a cell. And also, it is used to compare the EMFs of the two given cells. Now, we are going to discuss applications of the potentiometer. Let us discuss first application, that is comparison of EMF of the two cells. Okay. In potentiometer, there are two circuits. One is primary circuit and another is secondary circuit. A source cell of EMF E, plug key and rheostat, that means variable resistance. These are connected in one circuit. That circuit is called primary circuit. And the cells whose EMFs to be compared, those are connected in the another circuit. That circuit is called secondary circuit. Right. And the positive terminals of these two cells are connected to the positive terminal of the source EMF. Now, let us discuss how we can compare the EMF of the ratio of EMFs of the two given cells. Right. Observe carefully. By closing key K1, a cell of EMF E1 is introduced in this circuit, so that the current is flowing along this direction. The current is flowing along this direction. And open the key K2. That means open means here switch off, close means switch on. There is no current passing through second battery. Now the current is passing through first cell along this direction, and this is a galvanometer, and this is called jockey. Okay. Now take this jockey, press at different points on the potentiometer wire, and always you must see the readings of the galvanometer. Now here the galvanometer looks like this. This is 0, 10, 20. 10, 20. That means using this galvanometer, this is the galvanometer looks like a lab. Using this galvanometer, we can easily find out magnitude of current as well as direction of current, right side and left side. 0 is located at the center of the scale. Now jockey is pressed at different points on the wire until the deflection in the galvanometer becomes 0. Once deflection in the galvanometer becomes 0, then there is no current flowing between the primary circuit and the secondary circuit. At this situation, the potential difference between these 2 points, for example, this point is A and this point is C, this end point is B, is balanced by the EMF of the first cell. That means here this length is called balancing length. That means balance means what? At what particular length the current in the galvanometer balance. It is located exactly at the center 0. That particular length on the wire is called balancing length. Now in this case, the potential difference between the 2 points A and C is balanced by the EMF of the first cell. So that's why the current in the galvanometer becomes 0. Now E1, EMF of the first cell, is equal to, what is the potential difference between these 2 points? I, the current passing through the circuit I, and the length between the 2 points L rho, IL rho. Equation 1. Right. Here rho is always constant. Resistance per unit length of the wire is constant. Okay. Does not change. Now, open key K1. Open key K1 and close key K2. Open key K1 and close key K2. Now what happens? Whenever this key is open, the current is not passing through this first cell. It is passing through second cell. Why? Because second cell of EMF E2 is closed. The current is comes along this direction. That means this E1 cell is disconnected in the second case. Now the E2 cell, a second cell is introduced in second time in the circuit. Now repeat this experiment as in previous case. Place jockey at different points on the wire and show every time, see every time the readings of the galvanometer, and do this experiment until the deflection in the galvanometer becomes 0. Once the deflection in the galvanometer becomes 0, then note the balancing point in the second case. For example, the balancing point in the first case is nothing but L1. In the second case, the balancing point is L2, and the potential difference between the 2 points is IL2 rho. This potential difference, for example, if we place galvanometer jockey somewhere here, then the potential difference between these 2 points is balanced by the EMF of the second cell, E2. E2 is equal to IL2 rho. This is equation 2. So in this way we complete this experiment and take the ratio first to second. E1 by E2 is equal to, here, IL1 rho divided by IL2 rho. Rho cancel, II cancel. E1 by E2. E1 by E2 is equal to L1 by L2. So E1 by E2 is, so by knowing the values of L1 and L2, we can easily compare the EMF of the two given cells. So this is the process of the comparison of EMF of the two given cells using potentiometer instrument. Okay, now we are going to discuss a second application. What is the second application? Using potentiometer, how you can find out internal resistance of a given cell. Right. Let us find out how. As discussed in previous case, potentiometer consists of two circuits. One is primary circuit and another is secondary circuit. A cell whose whose internal resistance is to be determined, that cell is connected in secondary circuit. This is secondary circuit, and there is a resistance connected, external resistance is connected parallel to this cell, Now let us do this experiment. First, open key K1. Open key K1. Whenever this key is open, there is no current passing through this resistance, and the current is passing through along this direction, galvanometer and a jockey. That means the cell is introduced in the circuit. Now do this experiment as discussed in previous case. Place jockey at one end of the wire and press different points with jockey on different points on the wire until the deflection in the galvanometer becomes the current deflection in the galvanometer becomes 0. Once the deflection is 0, then measure the balancing point between these 2 points. Between these 2 points on the wire. Now, in this situation, the EMF of the cell E1 is balanced by the potential difference between the 2 points. Potential difference between the 2 points. Now, close key K1. Close key K1. So that what happens here, this circuit becomes closed circuit. In previous case, this circuit is in open circuit. Now in this case, this circuit is in closed circuit. Now repeat the experiment as discussed in previous case. Place the jockey at one end of the wire and press jockey at different points on the wire until the current in the galvanometer becomes 0. Once the current in the galvanometer becomes 0, the current is balanced. Note the balancing length in the second case as L2. As L2. Now, since this circuit is a closed circuit, now the potential difference between the two terminals of a cell in a closed circuit now we call as terminal potential difference. Terminal potential difference. The terminal potential difference is V. That V is balanced by IL2 rho. IL2 rho. IL2 rho means what? The potential difference between the 2 points on the wire. So this is equation 2 and this is equation 1. Here, please remember, in the first case, the cell is in open circuit. Now, the potential difference between the two terminals of a cell is called EMF. That EMF E1 is equal to IL1 rho. But in the second case, whenever we close key K1, the circuit becomes a closed circuit. Now the potential difference between the two terminals of a cell is now called as terminal potential difference. This is the basic definition. V equal to IL2 rho. V equal to what? IL2 rho. Now, doing the division, first equation with the second equation. So, E1 by V is equal to IL1 rho divided by IL2 rho. Rho cancel, I cancel. So, here E1 by V is equal to, we get L1 by L2. This is equation 3. And also, we have to know one important relationship between terminal potential difference and EMF. This is the relationship. E1 is equal to V plus IR. This is the relationship between potential difference, terminal potential difference and EMF. E1 is equal to V plus IR. Right. E1 is equal to V plus. Here, what is high here in terms of terminal potential difference across the resistor? I equal V by R. The terminal potential difference across the resistor is nothing but V. So, V by external resistance R. External resistance R into small r. Okay. So, E1 is equal to, here take common V 1 plus small r by capital R. Now, E1 by V is equal to we write here as 1 plus small r by capital R. This is equation 4. Now see this third equation. Third equation is E1 by V is equal to L1 by L2, and fourth equation is E1 by V is equal to 1 plus small r by capital R. These two equations are equal. 3 is equal to 4. Equate these two equations. That means 1 plus small r by capital R is equal to L1 by L2. Small r by capital R is equal to L1 by L2 minus 1. Okay, small r by capital R is equal to, here do LCM, L1 minus L2 by L2. Now we want to find out what? Small r. Small r is equal to capital R into L1 minus L2 divided by L2. So this is the expression to find out the internal resistance of a cell using the potentiometer. By substituting the values of L1 and L2 and external resistance R, we can easily find out the internal resistance of the given cell by using the potentiometer. So in examination, how the question asks? The question asks like this: what is the principle of potentiometer, and by using this potentiometer, how can you find out? Number one, they may be asked first case, how can you compare EMF of the two given cells, or they may be asked in second case, how can you find out the internal resistance of given cell by using the potentiometer. So in two cases, they may be asked only one case and a principle. That is 8 marks question. Okay. So this question is very important current electricity.